Hello ladies and gentlemen, today we're going to be implementing circle drawing into my game engine. Now we're going to be using midpoint circle algorithm. This algorithm is very simple, so you don't have to worry about not understanding it. I will also explain how it works as I go on. So the whole algorithm relies on one equation basically, and that is this equation. This is how you get a circle's radius, right? So everyone, I hope, knows this. And so we have a circle, right? And we're going to basically take a look at its coordinate system, right? So this is 0, r, right? This is 0, 0, this origin point. And this is r, 0. This is 0 minus r. And this is minus r, 0, right? So what we're going to be doing is drawing each pixel of this circle one by one. And to do that, we're going to be taking advantage of this equation. So first, let's get the x position of each pixel, right? So we're going to be iterating through minus r until r, right? So we're going to our x position is going to be starting from minus r until and equal to r. So we're going to be going through like this. But that's the only x position of the pixel, not the y position. To get the y position, we have to rearrange this equation terms a bit. So we're going to be doing y equals to be r squared minus x squared, right? So if we make it a bit more simpler, it's going to be like this. This is how we get the y position. And this is basically the entire midpoint circle algorithm, kind of. This is the first part of it, and this is not enough to draw a circle, but we will see. So there is also another problem here, where this y, we only draw the bottom half or one half of the circle, not right? So because we only get one xy, so this is one xy. So we put two xy, we put another one, which is the minus y, because we draw the first half of it, first half's pixels, so we draw the other half's pixels as well. That's how it is. So let's just implement this and see how it works, right? See if we did make any mistakes, see if we understand this correctly, right? So our radius is going to be 32, right? And I'm just gonna calculate it here, radius squared, easy. So, and we need to get the x and y positions. So var x, I'm going to be using integers, by the way. So this is going to be I32, 0. No, our initial starting point is minus r, right? So we're going to be starting from the left side of this thing, left side of the circle, to the right side of the circle. We're going to go through from left to right. So we're going to say while x less than equals to that than radius, we're going to be incrementing x by 1. Right? So now we need to calculate the y position. Y is now this is going to have to be float, but let's just do a float for this one. We will do integers later. Let's just use floats. This is going to be square root of r squared minus x squared, right? and this is the square root. And this is how we calculate the y. And this is exactly like this equation here. So we get the y position. Then we're going to be drawing the pixels. One for one half and the other half. So 2 pixels. Draw pixel. And this is going to be the renderer. And the position is going to be x and y. I'm going to turn this into its own type here. Like this, so it's going to be a bit easier for us later down the road. You'll see why. So I'm just gonna say, well, we need to, fuck, okay. I'm just thinking about the future, so it's not really related to the algorithm I just described, but let's do it this way. It's a bit more verbose to do, but you'll see why I'm doing it this way. So the color is just going to be white for now. Right. Then this does return error, so on error we're just gonna panic and say renderer failed to draw circle. Error is this thing. Right. Okay. So this is only one half of the circle, and let's actually see if it is one half of it, right? Let's see. Now it's going to be on top left corner of the window. So let's just reorient it, right? And might as well just remove these draw calls as well, so it's not polluting the screen, right? Okay, so as you can see, it's only top left. And we don't know if it's one half or the whole circle, right? Because we can only see this top left, one half of it. So let's say offset, and this is going to be a vector too. And let's say it's 300 by 400 or something like that. And then we can add this to offset. Let's make it like that so it's easier to see. And let's increase the radius a bit more so it's a bit more easy to see on you guys. For you guys. Okay, so I increased it a bit too much, so let's make this 200 by 300. But you already saw that it was only the bottom half, yeah? Okay, so you can see it's only the bottom half. Because we only draw one pixel, right? So we need to draw the other pixel, and how we do that? We basically say, okay, so we only drew this half, right? So what we need to do is draw this half. So what we can do, oh, look at that. R is positive here and R is negative here. So we just need to negate it, right? It's that simple. And we just say, we say 2 draw pixels, and one is negative y, one is positive y. And that's how we draw 2 sides of this circle, 2 halves of the circle. As you can see, this is a circle, but there's a problem. The sides are not really drawn properly, right? So this is where the midpoint circle algorithm takes us to a near perfect circle, right? What we do is we draw, we basically draw one portion of a circle. So there, as you can see, there's 4 portions. 1, 2, 3, 4. 4 portions of a circle, right? So what we do is draw one portion, and every other portion is basically mirrored to that portion. Because circle is symmetric, we can just mirror the one portion, right? That's how we do that. So let's do it, right? Okay, let's do it. So we're going to be first getting one portion and drawing one portion. So, and to do that, we basically multiply the radius with the cosinus that's divided by 4. Right? This is one portion of it, one portion of the circle. And we're going to be starting from, I'm going to be using now integers, unsigned integers. The reason why, because the square root algorithm on integers a bit faster than float one, at least in Zig standard library, I think. So that's why I'm going to use. Although it doesn't really matter, you can use float as well, yeah. So anyway, so we're going to be starting from 0. Right, and we're going to be iterating through 0 to the L. This is one portion of the circle. We're going to be incrementing by 1, and y is also going to be u32, and we're going to be using the standard library square root function, and it is a generic function where it dispatches, if it's float, it's just use the xsquared, the built-in one, and if it's not float, it's unsigned integer, it's going to be using this algorithm here. I don't really know how this thing works entirely, but I at least know that this is faster than the float one. So that's what we're going to be using. And this is going to be like that. And now we need to turn these x and y's to floats in here. Float from int, right? And we do the same for the other part of this. And this is minus y. Now, this is not going to be complete. Oh, I didn't turn this into integer. Hold on. This is int from floats. And the negative part of it is going to be in here. Honestly, I kind of want to use integers for this. But okay, let's just use floats. Fine. It's too much trouble, right? It's too much trouble. Let's use floats. We are kind of losing precision with floats here, though. That's why I don't want to. I mean, we're not really losing anything meaningful, but I guess it's fine. I guess it's fine. Anyway, so this is not going to give us the whole circle because we didn't mirror it, right? We only mirror. Let's try to see what we get by this. We didn't mirror it, but we're going to get something, right? So let's see. So as you can see, we get the bottom and top right half of the circle, right? So there needs to be one here, another one here, another one here, another one here, and another one here. So we need to mirror it basically 8 times. We need to draw 8 pixels per iteration. So this is that. It's the same logic with the first mirroring we did. So we did draw the bottom half and top half by negating the y. Now we negate the x, right? So we negate the x, and we get half of the circle complete. Half of it, not entirely. As you can see, this is the half. We draw 4 portions, 4 segments, or we can call it like that. We draw 4 segments of a circle, and now we need to draw the sides. And to do that, we basically, because circles are symmetric, we swap the y and x positions, and we do this entire thing one more time, and this x is swapped. This is x. What the? Okay. Y, y, x, y, x. There you go. Now we get the complete circle. There you go. We get a complete circle. And that's really all there is to it. This is how you draw a circle using the midpoint circle algorithm. Now, this is not really optimized because we are using square root, and square root, calculating a square root of something in computers, it's really hard on computers. So you probably should approximate the square root. But we're not going to be doing that today. But what we're going to be doing today is filling this circle in. Because we only draw the lines, the outline of the circle, right? We didn't fill it in. So I want to be able to fill it in. And this is actually way more simpler than draw what we did just now. So what we're going to be doing is, taking a look at very interesting property of a circle. So the pixel can never be bigger than the radius. The pixel position can never be bigger than its radius, right? So its x and y coordinates can never be bigger than its radius. It has to be equal or less. So by this logic, we can just iterate through its radius, right? So this is the radius. Let's make it a bit smaller this time so we can differentiate it. Or we can just comment this out. And let's copy some of this stuff in here. Okay. So we're not going to be using L, by the way. And we're not going to be using R squared. Well, we're going to be using that. Okay. So we're going to be doing something like this. This is minus R, and we're also going to have minus Y here. They're both going to start from the minus R. So we're going to go through Y first, right? And this is Y plus 1. Then for each Y, we're going to be setting the X position to minus R. Then we're going to go through each X position as well. There's a lot of iterations here, so it's not that optimized, but you'll see. And yeah, we're not going to be using the R squared. Okay. And we're going to be drawing pixel per this iteration. Oh no, we are going to be using the R2. Sorry, because we need to make sure that the X plus Y, this has to be squared, by the way. And let's say the Y squared is here. So it doesn't have to calculate that every single loop. Y squared has to be less or equal than to the R squared. And then we draw a pixel at its specified coordinates, like this. And this is the entire filling, the draw circle, but it's filled algorithm. So you basically go through its X and Y position of the circle, and you check if X squared and Y squared is less equals than the radius squared, and that's how you know you're in bounds of the circle, so you can draw it inside of it as well. and we get a white circle. Great. So, but let's optimize this a bit, right? We can optimize this a bit because drawing pixel for every single pixel in a circle is kind of wild, and it's wildly inefficient, right? So what we can do is cut it in half, right? Just like we did with this first one we draw with this algorithm, right? We draw only one part of it and then mirror it. So what we can do, start from 0. Or we can just start from minus as well. And we can say, okay, until 0, so it's only 1/2 of y and 1/2 of x, right? And let's put this if foundation here, and this one like this. Okay, so this is going to draw only one portion. Let's see what's going to draw, right? One segment of the circle. As you can see, now we divided a circle to 4, so this is going to be one portion of it. So what we're going to be doing is just, okay, so this is the one portion, so okay, I guess we can just negate the y and get the bottom half, right? Yeah, okay, we got the bottom half. So we could do 2 more draw pixel calls to get the other half of it, but what we can do, draw lines, right? Draw line. This is the starting position of the line, and this is the end position of the line. So the line is going to go until it's minus x, and this is going to go until it is minus x and minus y. So we're going to be drawing from one half and the other half. As you can see, we get a complete circle. Okay, so quick interjection here. I kind of didn't explain something in this draw circle algorithm here. We are using draw line, but we are still drawing quite a lot of pixels. So we are still drawing each iteration, almost each iteration, as long as this condition is met, right? We are drawing more than one line in the same x-axis, right? So this is still too much draw calls. So I kind of forgot about this when I was explaining in the video. But although this works, we are still drawing too much pixels. We are still drawing too much lines here, too much draw calls. And if you want to optimize this a bit further, we kind of take advantage of this algorithm again, this equation again. So instead of rearranging it for y this time, we can basically do the same thing as what we did for y, right? For the line function. Oh, excuse me, this is going to y. So we got a square root of r squared minus x squared, right? And that's how we drew the lines of the circle, drew the outline of the circle. And now instead of just the outline, we can basically use the same algorithm here, and we can just say, okay, get rid of this while an if statement here, right? Get rid of this entirely, and get rid of this. We can then do x is square root of r squared minus y squared, right? And we can just do it like this as well. And now we don't have another loop here, and it's just only one loop, and now we're drawing the entire circle and we are filling it as well. And there is way less draw calls now. Hopefully it will compile. Okay, yeah, as you can see, it's the same circle, it's filled again, but it's now using less draw calls. And that's what we really need. We need less draw calls, and so it's faster and easier on the GPU. We are still using a square root algorithm function here, but I think it's worth the trade, and that's the end of the interjection, I think. Yeah, back to the video. And this is really it. This is whole algorithm we are going to be, well, we did just implement it. I'm going to basically now put this into the a function, and we can use it. So, okay, let's do that. Draw, let's call it draw. This is draw pixel. Let's just move this a bit more like this, so that makes more sense. This is the rectangle. We can put it in here, right? Let's call it draw, or we can put it after the rectangles. That's the rectangle. Okay, let's put it in here. Draw circle, and let's start with the line. And this, it's going to take itself. It's going to take a renderer. And it's going to take the position. And it's going to take the radius in float. And it's going to take the color. And this is that. And that's really it. It's going to have a draw error. You can return that, and it's going to return nothing. So we're going to be using. So let's just copy and paste the this algorithm here. Copy that and paste it in here. Okay. Comment it out, and these are the renderers. And okay, one more. There you go. So these log panics needs to go, and we can do something like that. Let's try. There you go. Try. There you go. Try. There we go. Boom. Boom. Yeah. Boom. 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 Okay. Boom. There's too much of them. Okay. There we go. Okay, that looks better. Jeez. And these are not renderer. These are self. Right. These are self. And this is the. We're going to do the offset later, and these are going to be color. Oh fuck, color. There you go. Radius is just going to be radius here. And position is going to be this thing, right? So offset is the position. Now there's one problem with this, is that we are drawing from center of the radius of the circle, right? Because we start from the left end and go to the right end of it. So we are kind of drawing from its center. We kind of start, our origin is center. So we need to add the radius in here, basically. So this is the radius, and that's how we can offset it to the top left, right? So this is draw circle lines, and let's test it if it works. Right, let's remove this thing. Let's call renderer draw circle lines, right? Let's copy some of this. This is the position. Let's make it 0 so you can see it's going to be top left. And let's make the radius 32. Let's make the color, oops, red. 0, 1, and there we go. And this can return an error. So renderer failed draw circle lines error. I can't type today. Okay. There we go. So this is going to draw a circle line in 0, 0 when the origin is going to be top left of the circle. So it's going to be visible entirely. Yeah, there you go. If you didn't do that, it's going to be the origin of the circle is going to be the middle. So we're not going to be able to see it. And let's see that, right? Let's actually see that. Right. Okay, as you can see, the origin became the middle of the circle. That's why we are adding the radius to the offset. So that's draw circle lines. Now let's create draw circle, right? Circle. And we're also just gonna copy paste this thing. Boom. And the offset is just going to be this thing. And we can do that. And R is going to be radius. And these are self, just renderer, and no panics, tries, return the error. And can we, it doesn't look good. Okay, we can just do it this way. And the color, right? This is the color. Wow, okay, color, there you go. And that's the whole thing implemented into functions, so this should work as well. So let's call this draw circle, just circle, and this is going to be like 200 and let's say 500 or something, and it's going to be now let's just make it like 100. It's going to be too big though, so let's make it 50, and let's make it this color, whatever that is. And we see nothing. Great. Okay. Did I do something weird in there? Position. And okay. Okay, wait, what happened? Why did it not work? Okay, let's make this 0, 0. And let's not draw these lines. Oh, fuck, I closed the thing. recover these. Okay, let's not draw this. And let's draw this in 0, 0. See what we did wrong. Right. Okay, so 0, 0. It is correct. So I think it just went out of bounds. How big is my oh, it's the maximum size is 500. That's fine. Okay. Let's make this 700 by 700. So that should do it. That's fine. Okay, there we go. And let's draw the circle lines as well. Okay, there we go. Now it does work. Okay. And let's comment these out so they are there as well. See anything interesting? Okay, why is it not opening the okay, thank you. Okay, now yeah, it seems to be working as expected. Let's make this not pink, but like a bit more blue. Okay, and I will put this into like 600 and 100, so it's a bit better. And we're going to be okay, that seems to be working. So I think I'm just gonna left it here because I kind of want this to be video to be short. So yeah, that's going to be it. So that was the midpoint circle algorithm basically. We can do a bit more optimizations to the algorithm, so we don't have to use the square root because square root again is expensive, and you can see how can that be done in this Wikipedia article. You can use this one, the JSCO method, or you can use the Python method implemented in here, but we're not going to be doing that. So anyway, that's going to be it today. Hopefully you liked it, hope you learned something today, and I will see you on the next one. Bye bye.